Hi everyone, welcome back to Teaching Math. In this short video, I'll give you clear step-by-step instructions on how to convert terminating and repeating decimals to fractions and fractions to decimals. We will look at quick shortcut for most repeating decimals and one example where we will use the algebraic method. Let's get started. All right, let's refresh our memory. What are terminating and repeating decimals? Terminating decimals stop after a few digits like 0.5, 0.75, 3.125. As you can see, the number stops at 5 in each one. Repeating decimals continue forever, but with a pattern 0.333 and 0.12, 12, 12, 12. Even though they look different, both types can be written as fractions because they're rational numbers, and that's exactly what we'll do next. When converting a fraction to decimal, all we do is divide the numerator by the denominator. Let's look at 3 examples. For 1/2, 1 is our numerator and 2 is our denominator, which means 1 divided by 2. You can use a long division to work this problem. So let's go ahead and do that. 1 divide by 2. So 2 cannot go into 1. So we add a 0 and a decimal, and we put a 0 here. 2 can go into 10 5 times. 2 times 5 equals 10. And we end up with 0. So the common confusion here is when the students divide 2 by 1 instead of 1 by 2 because 2 is a greater number. So let's go ahead and do the second one. 3 divide by 4, which we can write as a long division. 3 divide by 4. And 4 cannot go in the 3, so therefore we're going to put a 0 and decimal. And then make this as 30. 4 can go inside 37 times. So we're going to have to write 28. 4 times 7 is 28. Subtract that, then we have 2. We're going to bring down a 0. And 4 can go inside 25 times. 4 times 5 is 20. Now we have 0. As you can see, we're easily converting. Let's go ahead and do the third one. 2 divided by 3. 3 is greater than 2, so we're going to put a 0 and a decimal here and make this as a 20. So 3 can go inside 26 times. That will be 18. I'm going to subtract 18 from 20. And then we're going to see that this keeps on going, right? As you can see, it's still going to be the same number. So this is going to keep on going. Our answer would be 0.666 dot 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 or 0.6 with a notation bar. Now let's go ahead and convert terminating decimals to fraction, basically doing the opposite what we've done before. Before it was fraction, we converted to decimal, and now we're converting decimals to fraction. So here's the thing, when the decimal stops, you can always write it as a fraction with a denominator of 10, 100, or 1000, etc., depending on how many digits are after the decimal. For example, 0.5 has only one digit after the decimal, therefore we can divide by 10. Remember, we're dividing either with 10, 100, 1000, and etc. Okay, so this will be 5/10. Now, we can't stop here. We wrote it as 5/10, then we have to simplify. Well, both numbers can be divided by 5. So what we do for one, we do for the other, and so the answer will be 5 divided by 5 equals 1, and then 10 divided by 5 equals 2. 1 over 2. Let's try the second one. 0.25 has how many numbers? 1 and 2 after the decimal, and therefore we're going to divide this by 100. Then again, we're going to go ahead and simplify. Both numbers can be divided by 25, and therefore our answer is 1. 25 divided by 25 equals 1, and then 100 divided by 25 equals 4. 1 over 4. Let's try the last one. It seems more complicated, but let's try. 0.125 equals how many numbers after the decimal? We're counting 1, 2, 3. That means we're going to write 1000. Divide by 1000 because 1000 has 3 zeros. All right. In here, we're going to do the same thing. Simplify. And when we're simplifying, we're going to divide both numbers by 125. What we do for one, we do for the other. So the top number will be 1 and the bottom number will be 8. So the rule is simple. Count the decimal places, write it over a power of 10, then simplify. Now for repeating decimals. There's two ways to convert these, the shortcut method and the algebraic method. Most of the time you will be using the shortcut method, but there are some times and some numbers that we will need to use the algebraic method, and I'll show you in a minute why. Let's review the rule for shortcut method. If one digit repeats, divide by 9. If two digits repeat, divide by 99. And if 3 digits repeat, divide by 999. Let's go ahead and take a look how that works. Question 1, 0.3 is the same thing as saying 0.333. So our rule says if one digit repeats, in here there's only 1, divide by 9, so therefore it will be 3 divide by 9, and then we have to go ahead and simplify. So the key here is to write the fractions in the simplest form, and the answer will be 1 over 3. Let's try the second example. Now, our second example is showing that two digits repeat. Therefore, this is written as 12 and 12, dot, dot, dot. So we're going to divide by 99. And here again, we're going to think about how are we going to simplify. Well, both numbers can be divided by 3. So let's go ahead and divide by 3. And so the answer will be 4 over 33. Last question. As we can see, 3 digits repeat. So we have 0.538, and therefore we're going to divide by 999. So 538 divided by 999. Here you have to think about, can I simplify this? So the answer is no, we cannot simplify it. Now here's where the shortcut doesn't work, when the repeating part doesn't start right away. In this number 0.1666, only 6 repeats, but the 1 doesn't. This means the repeating starts at the second decimal place, so we will use the algebraic method because the shortcut will not work here. Let's define the decimal. Let's call it x equals 0.1666. Now let's do the second step, which will be moving the decimal once to get the repeating part lined up. We want the repeating 6 to come right after the decimal, so multiply both sides by 10. That will be 10x equals 1.666. Step 3, let's multiply both sides by 100 so we can match the repeating digits, so we can eliminate it at the end. 100x equals 16.666. As you can see here, the repeating digits are on the right side of the decimal and they are aligned. To subtract the first equation from the second. So let's go ahead and do that. $10x equals 1.666. Here you can clearly see if we subtract, you will be able to eliminate the repeating digits. And therefore, this will be 15 and 90x. The last step will be dividing both sides by 90. So our answer will be 15 over 90, which will be simplified to 1 over 6 if we divide both the numerator and denominator by 15. Our final answer is 1 over 6. All right, here's a quick recap. When we have terminating decimal, the shortcut will be either dividing by 10, 100 or 1000, basically the powers of 10. If we have repeating decimal and the repeating digit starts right after the decimal, we will divide either by 9, 99, 999, and so on. But when we have a mixed number, we will use the algebraic method. Now it's your turn to practice. Try these 3 on your own and then convert 0.65 into fraction, convert 0.2727 repeating to a fraction, and convert 7 over 8 to a decimal. Pause the video and come back for the answers. Welcome back. I hope you got your answers right. Pat on the back, you did such a good job. If this video helped you understand how decimals and fractions connect, give it a like and share it with your classmates, and subscribe to Teaching Math for more quick math tutorials. And remember, learning math takes patience, practice, and perseverance. See you in the next lesson.